Okay, good morning once again. Today we're going to have a review of what we have discussed so far about multiple linear regression. So let me just quickly review what we have done. What we have done the past lessons was to analyze and study the output of a linear model. In this case, it's only a simple linear model, but the principles behind the output will be quite similar to a multiple linear regression. So we generated this object model 1 where we regress hourly wage on education using data is equal to wage. And then we know that the summary looks like this. You have your intercept, and we have studied before the statistical test for this, the independent test of means for your beta null and your beta 1. Okay, we have studied the null hypothesis, and we have looked at how to interpret it. We have seen how to use the t-value in order to infer whether this particular this intercept or the regressor, the independent variable, is significant or not. In this case, based on both the t-value and the p-value, of course you have to compute for the t-critical, okay? And we studied that last time using the qt function, okay? And it turns out to be negative 1.96 something, and we know that the t distribution is symmetrical. So if it's less than negative 0.96, then it falls under the rejection region. But negative 1.31 is to the right of your critical value, so we fail to reject this null hypothesis. And also based on the p-value, which is greater than 0.05. So we have the same conclusion, we have the same inference. So the t-value inference and the p-value inference will always give the same answer. Here also education, okay, we were able to also compute for the t-critical. If I'm not mistaken, it was 3 something. And the t-value of education is greater than the t-critical. Therefore, we reject the null hypothesis that your p-value, that your beta 1 is equal to 0. And same thing here with the p-value, which is significant at 0.001. Okay, 3 stars here. And then we looked at this one last time. We learned about the residual standard error, the degrees of freedom, that's df1, which is equal to n minus k minus 1, where n is the number of observations, which is 526. The number of predictor is k, which is 1, and minus 1, so that's 524. We looked at the multiple r squared, 16.48%, which means that 16.48% of the variability of your dependent variable hourly wage can be explained by our model using education. Okay, which means that around 83%, more than 83%, cannot be explained by education. So we have to use other predictors in order to explain more hourly wage. The adjusted R squared, 16.32, is used to determine, to compare which among models is better. So usually we don't use the R squared because always, if you have a model where you have more variables, more predictors, it will always give us a higher R squared. However, with the adjusted R squared, we will be penalized for adding more predictors, okay? Because it doesn't mean that the more predictors, the better, not necessarily. Okay, we would like as much as possible to have a parsimonious model. The lesser the variables in trying to explain a greater chunk of the variability of your dependent variable, the better. Okay, and then we looked at the f-stat, 103.4 on degree of freedom 1, the number of predictors, and degree of freedom 2, which is your n minus k minus 1, and the p-value. And we said last time that the p-value here is not necessarily this exact amount because this is the minimum floating point. Okay, now we have to know how this is computed, and this is computed using the values for SSE, SSR, okay, and SST. Now this one, since this is also an inference of statistics, you have a p-value here. This one also calls for a null hypothesis. In order to explain the null hypothesis, we have to understand where this is being compared to. Okay, so this is model 1. This is actually being compared to, in the absence of any qualification whatsoever, this is being compared to what we call model 0. So let me just write model 0. Model 0, alt minus, is just your LM, hourly wage, regressed on 1, okay? Comma, data, your data is equal to also wage, comma, data is equal to wage. All right, then we summarize, summary natin si model, summary model. Okay, minsan, class medyo pasensya, naglolo ko tong Arcon, model 0. Okay, so what's this, class? This is just a base model. The tilde 1 here indicates that we're not using any predictor. Okay, we're not using any predictor. We're just using the dependent variable itself. If we take a look at this, control enter. So this is your output here. Okay, and if you take a look at this, the model is hourly wage regressed on 1, and the coefficient, the parameter is just the intercept. The intercept 5.896. So it means that there's no predictor that we're using here. And it's actually just the mean. Let me attach the wage, attach the data wage. Okay, and then the mean of hourly wage, it's 5.896, which is this one. Okay, 5.896. So model 0, which is hourly wage regress on 1, indicates that we're just using hourly wage as a predictor. Okay? Yun ang ano natin, kinuha lang natin yung mean niya. Wala tayong ginagamit na exogenous variable, which in model 1 is equal to your hourly wage, your education. Okay, so we can see here that the degrees of freedom is 525 because it's n minus k minus 1. Your k here is 0 because wala tayong predictor. Yung 1 will be for the intercept. No? The degree of freedom loss for the intercept. So that's why it's 525 as compared to 524 for model 1. All right? And, okay, so that's about it, no? Okay, so that's model 0. Now, when we go to model 1, let me go back to model 1. Let me delete this. Okay, sabi natin si model 1 class, yung summary niyan. Ito, no? Okay, it's important, class, to understand what is the null hypothesis for this. Okay, so ito si model 1, di ba? Model 1. Ang question, where are we comparing model 1? We are actually comparing model 1 to model 0. Okay, model 0 where you're not using any exogenous variable. So ito wala tayong predictor, no? Si ano lang, average lang ni hourly wage. Ito naman si model 1, may predictor tayo, education. Okay, ito none. Okay, no predictor here. All right? So, we call this, yung model 0 na to, ang tawag natin dyan, in relation to model 1, okay? In relation to model 1, model 0 is called your restricted model. Restricted model, si model 1 naman is called, it's called your unrestricted. Okay. Now, every time you're comparing models, okay, regression models, kung sino yung mas maraming predictors, siya yung unrestricted. Okay, kung mas konti yung predictor, siya yung restricted. In this case, si model 1 yung unrestricted. But if you're going to compare model 1 with another model with more predictors, model 1 now becomes the restricted. Okay, so it's relative. Yung restricted at unrestricted na to, it's relative depending on the number of predictors that is being used in order to model your dependent variable. So model 0, wala tayong exogenous variable na ginamit. Si model 1 may ginamit tayo, education. So si unrestricted, si model 1. Si model 2, model 0 ang restricted. Okay, that's very important because in identifying what's your null hypothesis for your overall goodness of fit. Ang tawag dito, class, overall goodness of fit test. No? Ano yung null hypothesis dito? The null hypothesis is to look at ano yung mga additional na exogenous variables na ginamit natin. Okay? And ask are these extra variables, are these predictors, okay, necessary? Okay, is it better to use them rather than just the restricted model? So dito, ang dinagdag natin sa education, di ba? So ang null hypothesis natin dito sa Anova na to, this is analysis of variance, is that null hypothesis is that ang dinagdag natin sa education, which is B1. So ang tinetest natin dito, B1 is equal to 0. Yan. That's our null hypothesis. Bakit? Kasi ang dinagdag natin sa education. Ang restricted natin, walang education. So gusto natin malaman, is the adding of education, which is B1 necessary? Baka pwede ng restricted na lang. Baka pwede ng B1 is equal to 0 na lang. Right? So that's what we're testing. So we're actually comparing model 1, where you have a predictor, education, and model 0, where you don't have any predictor. How did I know that? Kasi, ito, Anova to, no? This is an analysis of variance. Okay, let me show you that. Clear natin. Okay. If we run, so sa ilalim na lang, Control-Alt-I, if I run Anova ng model 0, okay, so let me call this Anov 0, which is Anova ni model 0. Okay, so I'm getting the analysis of variance ni model 0. I-run natin to. Okay, then i-print natin Anov 0. Okay, sorry. Anov 0, Anova model 0. Sorry. Dapat 0 to. Alright, gawin na natin to Anov 1. Nilolo ko talaga itong R ko. Anov 1, Alt minus, Anova. Class, please tell me if I'm going too fast. Kasi I know at the back of my mind, hinahabol ko yung lesson. No? Kaya baka masyado na ako napapabilis. Alright, I'm writing here a code. I'm creating this object Anov 0, which is the Anova analysis of variance of model 0. Now take note, si model 0, walang predictor yan. Si Anova naman, Anova model 1, may isang predictor, di ba? If we run this, let's see the comparison. Okay. So yung Anova ni Anov 0, you can see here, yung analysis of variance siya, ang response variable natin, hourly wage. Tapos, what do you notice? Wala siyang predictor. Alright? So meron siya ditong SSE, sum of the squares of your residuals, which in this case is the sum of the squares of your total. Okay? Kasi wala tayong sum of the squares of regression dito eh. Wala kasi tayong ginamit na predictor. Alright? And the mean, this is called the mean square error. It's just the average of your 7160 divided by 525. In-average lang natin siya. And wala tayong F value dito at saka probability kasi wala naman tayong tinetest dito. No? Yung model 0 natin, saan natin siya i-compare? Wala. Diba? Wala nang wala nang predictor yan eh. Ngayon tingnan natin itong model 1, yung Anova ng model 1. Meron tayong predictor, education. Alright? Degree of freedom, 1. Degree of freedom ng any predictor is always 1. Ang residual natin is 524, that's n minus k minus 1. No? And then, ito, class, sum of the squares of your regression. Naalala nyo kung paano nakuha to, di ba? May formula yan, which we studied before. I won't go, I'm not going to repeat that. No? It's an improvement of your model. It's the difference between your model minus the mean, right? And then square natin yun. Yun ang sum of the squares of your regression, in this case, education. Ito naman, sum of the squares of your residual. That's a difference between your actual value and your model value. Okay, ang total nito class is SST, which is this one. Okay, and then this class is the variation that was explained by education. So if you notice, if you divide your SSR by your SST, that SST is this one, or the sum of this one. If you divide the sum of the squares of your regression divided by the sum of the squares of your total, then you get your adjusted R squared. Okay, yun yung proportion ng variance ng dependent variable natin, hourly wage, na kayang i-explain ng model natin, in this case, education, which is our exogenous variable. Okay? And then meron tayong p-value dito, f stat, 103.36, and then the p-value. So, ano yung null hypothesis natin dito? Here we're comparing model 0 and model 1. Diba? Ano yung ano natin dito, hypothesis natin, null hypothesis? Again, i-compare natin, tandaan nyo model 0 and model 1. Diba? Si model 0, walang predictor. Si model 1, may predictor education. So ito yung nadagdag, no? So ang tinitingnan natin, B1 natin, okay, ang null hypothesis natin, B1, is that equal to 0? Yung dinagdag natin na predictor education, equal to 0 ba yan? And sabi natin, the p-value is practically 0, so we reject this null hypothesis. Okay? There is strong statistical reason to believe that our education, which is our B1, is non-zero. Statistically significant na non-zero. Ang ano niyan, ibig sabihin, implication, B1 can improve the model. B1, which is education, can explain your dependent variable, hourly wage. All right? And if you recall, di ba, kaya natin ma-compute yan, di ba? We can compute that. But let me just show you first yung comparison talaga, no? Okay. If we now create this model, okay, here, Control-Alt-I. Ito kasi Anova natin naka-separate, di ba? Naka-separate yung Anova for mod 0 and Anova for mod 1. If we compare that Anova, no? Anova ng mod 1, mod 0, at saka model 1. Take note, model 0 is your restricted, model 1 is your unrestricted. If we run this, okay, what do you have? Take a look at this. All right. So ito yung kanina, di ba? Hourly wage is regress on 1, hourly wage regress on education. You have the degree of freedom for your model 1. Di ba? 525 yung degree of freedom niya. You have the degree of freedom for your model 2, n minus k minus 1, 524. No? You have the sum of the squares of your errors, sum of the squares of your errors. No? You have your sum of the squares, mean sum of the squares. Okay? And then you have your f value and then your p value. So, di ba ang kino-compare natin dito is that class? Ang p-value natin, ang null hypothesis natin dito, B1 is equal to 0. So we reject the null hypothesis that B1 is equal to 0 because your p-value is very, 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 very small. No? Now, so just to make sure that we, just by way of quick review, okay, dito kasi medyo nagkamali kami kanina dito. I'd like to repeat this for the benefit also of the other section. Sabi natin, this one, ito, di ba, mako-compute natin to, madali to. Mako-compute yan. Everything here can be computed, class. This one is just sum of the squares of your errors. Okay, ito class, kasi ano naman, di ba? Ang ano niyan, ang formula niyan will be the actual value minus the mean. Di ba? And then square that. Okay? The actual value minus the mean, square that, and then sum that. That will be the sum of the squares of your total. Okay. All right. Tapos, how do you compute for your yung class, yung f, ba? Na-compute natin to by just, how did we compute for this? Yung f value na to, plus yung 103.36. Okay? So this is computed. I'll now write the formula. Okay, bibigay ko na lang sa inyo kasi in the interest of time, class. Okay. I wrote the formula here. Kanina medyo nagkamali ako sa ng LaTeX. I hope it's here. Did I write it here? Okay, here. All right. So pakisulat na lang ito, class, no? Control C. I'll share it in the chat box. Okay. Okay, so it's this one class, no? This is the formula for your F stat. So let me put here F underscore stat. Okay, so this is your F stat. Sum of the squares of your, in our case, error natin to, no? Iba yung gamit natin. Sorry. Pakibago na lang class. Yung R natin dapat errors, no? Alright. So sum of the squares of your errors for your residuals minus sum of the squares of your errors for your, this is your unrestricted. Ito yung model 1 natin, no? Alright. And then, sorry. Naka-small letter. Okay. Sum of the squares of your errors for your restricted model minus sum of the squares of your errors for your unrestricted model. Divide by Q. What's your Q? Your Q is your degree of freedom for your, we put this as capital R, just to be consistent, and this as your capital U. So that's the degree of freedom for your residual minus the degree of freedom for your unrestricted. Okay, sige. I-compute na natin to class for just to satisfy yung ano natin, yung our curiosity. Let's compute this. Control Alt I. Okay, number 1. What's our sum of the squares of your restricted value? Sum of the squares of our error terms. Okay, let's just get it from our value here. Okay. Why don't I copy this, no? Let me copy this above dun sa malapit sa model natin. Control C. I'll bring it up here. Ito. All right. Yan. Okay, asa na yung sum of the squares of our errors natin ng restricted? Diba ito yon? No? Ito yan, class. This is our restricted sum of the squares of our residuals. Okay, which is the sum of the squares of the total. Kasi wala naman tayong predictor dito eh. So that's 7160.4. Control C. Okay, so I'll put it here. So this is the sum of the squares of your errors ng restricted minus the sum of the squares of your errors ng unrestricted, which is this one. Diba? At kunin ko dito ha. You can get it here. It's this one. Okay. Ito na yan, no? Control C. Control V. All right. So that's the sum of the squares of your residuals, restricted minus unrestricted, and then divided by degree of freedom ng residuals minus degree of freedom of your unrestricted. So in other words, yung difference ng predictors sila, ilang predictors ba yung kakaiba nila? Ilang predictors yung nadagdag natin? That's your Q. That's your formula here. Ito. Yung Q. No? Ito yung restrictions natin. Okay, and it's equal to 1, diba? Kasi ang dinagdag natin yung education, diba? 525 minus 524. Nadagdagan tayo ng isang predictor, which is education. So that will be 1, right? Okay, that will take care of your numerator, okay? And then divided by, meron pa tayong pangalawa dito, no? This now will pertain to your unrestricted. Sum of the squares of your unrestricted minus the degree of freedom of your unrestricted. So our unrestricted is this one, ba? Control C, and then divided by 524. then parenthesis, control V. This is SSE, unrestricted, divided by degree of freedom, unrestricted. That's N minus K minus 1, that's 524. Okay, degree of freedom ng model 1 natin. Yan. Okay. So if we run this class, itong formula na to, na F-stat na yan, where we are comparing yung restricted versus unrestricted. Okay, tingnan yung formula, kino-compare natin yung unrestricted at yung restricted. And we get a F-stat equal to 103.36, which is exactly this one. Yun, 103.36. And then to determine if we should, so ang question, should we reject that, no? Should we reject that? Well, hanapin natin F critical. Dito na lang sa ilalim. So let me, pwede ko bang gawin itong F stat. F stat. No? Yan, F stat natin. Okay. And then our F critical, pwede natin gamitin ngayon si F underscore critical. We can make use now of yung natutunan natin dati sa natin. We use the Q, no? Pag probability hinahanap natin P. Pag hinahanap natin yung critical value, Q, no? Q and then F, kasi F distribution to. No? All right. So what are our parameters? P, okay. First, i-plot nga natin. Let me plot. Kasi pwede natin i-plot yung, yung whatever distribution. Merong package called Mosaic. Naman yung ko. Okay, I'm not sure if Mosaic na siya or Mosaic binago na yata. But let me try. Mosaic. Tapos pwede natin i-plot yung yung plot. Try natin to plot distribution. There's a function called plot distribution, and then ang distribution natin is, let's use the distribution yung F. Okay, you can of course use this for T, you can use this for normal. Okay, and then we defined our degree of freedom. Ang degree of freedom 1 natin is equal to 1, diba? Kasi ito yung model 1 natin. Degree of freedom 2 natin is, I hope this works kasi nag-error tong Degree of freedom natin is 524, di ba? That's N minus K minus 1. Okay? And then, lagyan ka natin ng color. It's equal to blue na lang, blue. Okay. So let's see if this will work. Okay, walang package na Mosaic. So kailangan ko munang tools, install packages, and then hindi ko pa pala na-load, no? So in your case, Mosaic. Mosaic is used for plotting. Yan, okay? Ang sabi, cannot open. Wala ba? Okay, let me check. Library. Mosaic. Or unless, palagay ko nagbago na sila. Dala, install that packages. Tagal ko na kasi hindi nagamit to, no? Mosaic. Mosaic plot na ba? Let me see this. Okay. Paki-check nga kasi nagkakaproblema ako sa internal Mosaic plot. Yan, no? Mosaic plot na siya. Let me see. Tools. Binago na niya yung pangalan. Na siya. Hindi ko pa na-update. Mosaic plot. Let me install this. Install. Okay. Ayaw mag-open yung connection. Okay, how about in your case, class? Is it loading? Paki-check nga, please. Let me try again. Ayaw. Nag-load ba sa inyo class? Paki-check naman please. Ay, ayaw. Nag-ano class yung ano ko, nag-internal server error ako. Kaya hindi siya nag-ano, hindi nag-work yung ano ko, yung help ko. So about in your case class, kindly help please. Kindly, plot is not an exported object from plot distribution. Saan siya galing? Are you sure? It's working for, okay, kay Jerome nag-work. Sandali. Jerome, ano nga? Since hindi ko hindi ako makaano eh. So, yan. So for some of you, it's working. That's very good. So may I just request, saan ba siya? Share all participants. Okay. All right. Sino ba? Jerome, I'll stop share. Pause share ako, stop share. Can you please share your output dun sa plot distribution?
Okay po, sir.
Pakita lang natin yung format ng F distribution. Thank you, Jerome. Yan. Pwedeng i-maximize mo. Okay. So ito yung F-stat, hindi siya kumpleto, no? But this is a portion of the distribution of the F-stat. Did this work in your case, class?
Yes, sir.
Okay, good. So F2. Okay. All right. So good. Salamat, class, no? Salamat for the feedback. Okay, so let me share ulit ako, Jerome, ha? Share. Okay, so hindi na ako mag-ano, I will not anymore show that. I'll just i-ano lang natin, class, yung critical value ng F natin. So let's compute for this. Ano ba yung QF natin, no? Ano ba yung mga kailangan dito? First is your probability, okay? And then your degree of freedom 1, degree of freedom 2. Okay, so ang probability natin is P natin is equal to 0.05, no? 5 level of significance natin. Degree of freedom 1 natin will be equal to 1. Okay? Degree of freedom 2 natin will be equal to 524. Okay, and then lower that tail. Okay, so gusto natin yung nasa right hand side, no? Is equal to false. So this will be our F critical. Okay, control enter. All right. So I'm getting 3.86. Print ko na to. How about you, class? Are you getting 3.86? Kindly chat, please, if you got 3.86. Feedback, please, class. Okay. Thank you. Hindi ko nakita yung reply nyo. All right. F. So that's 3.86, no? And di ba ang ang F stat natin is 103, ba? 103 F stat natin. So that's really to the right of our F critical, no? So that means nasa rejection region tayo. So we reject the null hypothesis that our B1 is equal to, RB1 is equal to 0. Okay, so there's strong statistical reason to believe that RB1 is a value other than 0. Okay. Any questions so far, class? Any questions? All right. So what we have done so far is, di ba nag-Anova tayo? No? Ito, no? We did Anova, Model 0, and Model 1. Okay, take note, we're comparing Model 0 and Model 1 here. Okay, and the formula to compute for the F statistics is this one. So you have your restricted model, which is Model 0. Restricted siya kasi mas konti yung predictors natin. In fact, walang predictor to, no? Average lang. Tapos si Model 1 natin yung unrestricted. Okay, so based on this formula, of course, class SSE, sum of the squares of your errors of your restricted, will always be higher than your SSE unrestricted. Kasi yung restricted natin, mas konti yung predictors niya. Okay, therefore, mas konti yung explanatory power niya, no? Mas konti yung ma-explain na model natin yan. That's why always your restricted model, your restricted SSE will be higher than your SSE unrestricted. Okay, so all right. Now there are other ito lang pinakita ko sa inyo yung Anova, no? This is coming from the stats package. There's another one. Okay, may one na tayo kanina, no? I'll just call it 11 kasi may Anova 1 na tayo. Also from the car package, but you have to make sure that your car is installed, hindi siya automatic, no? So i-library niyo muna si car, otherwise hindi magra-run to. Okay, I'm sure na-load na natin to dati. So i-library lang natin si car, tapos i-run natin to, and the difference is that this is capital A. Okay, capital A siya. Tingnan natin difference nito, no? Tingnan natin difference itong yung Anova 0 ginawa na natin kanina to. Tapos Anova 11, gawin natin Anova 1, which is your Anova mod 1. Okay, i-compare natin yung Anova at Anova ni stats package. This is stats. And we compare it with Anova 11 using car package. Right. So i-print natin pareho. Let's see the difference. Sa formula naman magkakatalo, no? Okay, and then this one also. Mag-Anova 1, 2 tayo dito. 1, 2. This time, we're going to use this AOV naman, no? So meron din yan, AOV. And let's, analysis of variance din yan. So let's just run this tree, no? Yung panay model 1. Okay, you run this. All right, so let's see the difference. Okay, so yung kanina, ito, di ba, degree of freedom, sum of the squares, mean, F value. Ito yung yung using small a Anova. Okay, yung big A Anova, ito naman. Okay, pretty much the same thing, no? Medyo nabago lang yung order, no? Diba? Inuna niya dito yung sum of the squares, dito yung degree of freedom. So nabaliktad lang. Okay? Sa big A, wala yung mean square. Wala siya. Sa small a, meron. And then, dun sa AOV, analysis of variance, okay? If you take a look at this one, stats AOV, all right. So, iba yung pinapakita nito, no? Iba yung niya. Iba yung way to present, no? So, magkakaiba yung presentation ni Anova, small a, tsaka Anova, big A. For me, personally, I prefer yung sa stats na small a kasi mas kompleto siya, no? Kaysa dun sa big A at saka yung AOV lang. Okay, so these are different ways in order to generate your analysis of variance, but they mean the same thing, class. No? They mean the same thing. You are comparing, okay? Kino-compare natin yung kailangan alam natin null hypothesis natin, no? Ang null hypothesis natin, tingnan natin kung ano yung nadagdag na predictor, okay? Tapos dapat alam natin kung ano yung restricted at saka ano yung unrestricted. Okay. So let's now go to the next one. Okay, punta na tayo dito, class. Let's go to our second model. Model 2 na tayo. Okay, so for model 2, let me share this with you in case you don't have it yet. Control C. Lagay ko na lang sa chat box, class. Alright. Okay, take a look at our model, no? Pareho lang actually to. So you have model 2 is equal to LM, hourly wage, regress on. Isasama na natin lahat ng exogenous variables natin sa data natin. No? As experience, tenure, race, gender, civil status, number of dependents. Okay? All right. So, and then in data, and it's just the same as tilde dot. Ang ibig sabihin itong dot na to, all your variables dun sa data wage, of course, except for hourly wage. Okay, so let me just run itong model 2 na to. Pareho lang naman yan, class. You may check. Okay, let's run this. And now let's take a look at our model 2. All right. So, let me rerun that. Rerun ko ulit, no? Summary ng model 2. Okay, para kasya sa isang line to. All right. You now take a look at this, no? So, andyan na yung mga predictors natin, yung mga independent variables natin na significant. Technically, tatlo lang yung significant, no? Si education, si tenure, at saka si gender, no? They're significant at 0.001. Si experience is significant kaso at 10%. So if our level of significance is at 5%, then hindi natin isasama to. No? Pero what's important here is the interpretation. Okay, so let's interpret this one by one. Okay, number 1 is education. Education is significant, no? It's significant at 0.001. All right? And then you have here your B1. 0.57. This is B1. So what does this mean? 0.57, it means that for every 1 year increase in education, there's a corresponding $57, okay, increase in hourly wage, ceteris paribus. What does ceteris paribus mean? Ceteris paribus means that only education, we will only increase education by 1, only education, and the rest will remain the same. Hindi natin dadagdagan sa experience, tenure, etc. So it's only education that we're going to increase by 1. Okay? 1 year increase in education will mean a 0.57 increase in hourly wage. Okay? Ceteris paribus, wag natin dagdagan sa experience. Kasi pag dadagdagan natin sa experience, may magkakaroon ng marginal impact din based on this. Alright? So that's the meaning of yung parameter natin na education. Ganon din si okay, so sa number of dependents, if this was significant, this would have meant that for every one unit or for every one person na i-increase ang number of dependents ng family, mag-i-increase yung hourly wage ng 0.14, ceteris paribus, if that was significant. However, it's not significant, no? Okay, it's not even significant at 0.10. Right? 0.17 yung p-value niya. Ganon din si civil status, etc. Now, I'd like to point out this one, si race, si gender, at saka si civil status. Bakit may naka-attach na white, male, at saka single? Bakit ganon? Why do we have that? No? Okay, that means, class, let's start with race. If I take a look at race, okay, i-table ko muna si race, ha? Okay, table, and then wage, race. We can see that there are two types of race, non-white at saka si white. Now, ang default ni R is that kung sino yung alphabetically mauuna, okay? Alphabetically mauuna, siya yung magiging benchmark. And the benchmark will get a value equal to 1. No? Si white, okay, magiging ang value niya 0. Now, since there are two values here, there are two levels, what R will do is that yung mga factors na ganito, yung mga character variables na to, that can be used as factors. Remember, ano yung factors? Factors are character variables or categorical variables which can be used as a classifier. So, si non-white at saka si white, although character variable yung mga yan, ang class na character, pero pwede siya magamit na factor. So, automatically si R, ang ginawa niya, ginawang factor tong si race, no? Tapos, ang ginawa niya, nag-introduce siya ng dummy variable. Now, paano ini-introduce yung dummy variable? Okay, let me just show that. So, asan na yung wage natin? Ito. Okay, wage. Ito, no? Alright. Remember this, si race, ano siya? Yung categorical variable, which can be used as a factor. So, sabi natin, si non-white, magiging 1, si white, magiging 0. Since there are only two levels, okay, we can introduce always n or level, let's say q, kung ilang levels, minus 1. Dummy variables. Okay, let me repeat. Ilan yung levels ng race natin? Dalawa, non-white at saka si white, no? So, ilang dummy variables ang introduce? The number of levels, q, minus 1. So, since there are two levels, minus 1, so it will only introduce one dummy variable. Isa lang. In other words, papalitan niya to. No? So, lahat ng white, okay, gagawin niyang 0. Magiging 0 to, 0, 0. So, lahat ng white, magiging 0. Si non-white, gagawin niyang 1. Okay? Kunyari non-white to. Bakit 1? Kasi si non-white, siya yung magiging benchmark variable. Okay? Benchmark variable si 1, si non-white, so it will become 1. Same thing with gender. No? Si gender, dalawa lang. Dalawa lang din. Kunin natin yung table niya, you have female at saka male. Since female appears alphabetically first, then ito yung magiging benchmark. Of course, you can change this. So pwede tayo mag-assign kung sino yung benchmark. But for now, let's just use a default. Si female will be 1, si male will be 0. Okay? Now, since there are only two levels, how many dummy variables will R introduce? Class. Ilang dummy variables ang i-introduce ni R? Answer? Paki-chat, please. How many levels? Two levels, male and female. How many dummy variables? Yes, correct. Only one, no? Only one lang kasi the number of levels, which is 2 minus 1, so it means 2 dummy variables. So, ibig sabihin, yung gender natin, isa lang din na variable yan. Where female will become 1, so this becomes 1, 1, male becomes 0, 0, 0, 0, 0, 1. Okay? So which means lahat ng situations na capture nitong dummy variable nito. Okay, ganun din kay civil status. Married, since alphabetically mauna siya, becomes 1, single becomes 0. So this will be converted into 0, 1, 0, 1, 1, 1, 0, 0, etc. Kaya nga, itong mga factors na to, pwedeng gamitin na regressors, no? Regressors. Pero yung pag-interpret yan, we will discuss in a while, no? So magiging regressor siya kasi factor siya. Now, kung character, tapos hindi naman pwedeng regressor, hindi natin siya pwedeng gamitin, hindi siya pwedeng gawing factor, then we're not going to use that. No? For example, address. Okay, address. Uh, ilang yung addresses natin, individual addresses, unless that you would want to use that as a classifier. Siguro pag city born. Yan, Manila, Makati, wherever, diba? Yun pwedeng pwedeng factor yun. Diba? Let's say pwedeng kunyari zip code. Zip sometimes can be used as a factor kung anong area, no? Or province, etc. So there are variables that can be used as factors, but there are variables that cannot be used as factors. All right, let's have another example. Suppose meron tayong year level dito. Year level. Tapos yung year level na yan, ando dyan, frosh, sophomore, senior, junior, frosh, sophomore, senior, etc. All right, question. How many dummy variables are we going to have here? Paki-chat please. How many dummy variables are we going to have in this for this factor? Yes, correct. That's 3. Bakit? Kasi 4 levels minus 1. So how will that look like? Anong magiging itsura ng dummy variable niyan? So let me illustrate that. Okay. Clear ko muna yung drawings natin. All right. So let's suppose meron tayong dummy variable, year level. So ang gagawin ni R, hahanapin niya frosh, sophomore, senior, junior. Since frosh is the alphabetically will arrive first, will appear first, siya yung magiging benchmark. Okay, so ano mangyayari? Ang mag-i-introduce tayo ng dummy variables, ito. So sophomore, let's call it SO, junior, and then senior SE. All right. Okay, sabihin natin ano to, frosh, sophomore, senior, junior, senior, etc. You'll get the idea already. If it's frosh class, then ano to this is SO, no? SO. So hindi siya sophomore, hindi siya junior, hindi siya senior, ba? So zeros here, all 3 zeros means frosh yan. Okay, so notice na tatlo lang pwede na. Tatlo lang variables, dummy variables ang introduce natin, pwede na. We're not going to introduce another variable here, frosh, to make it equal to 1. Eh, bakit? Kasi pag nagkaroon ka na pa ng isa pa, we will have what we will call multicollinearity. Magkaka-multicollinearity tayo niyan. And remember, we don't want this. And also, it's another way to call it is a dummy variable trap. Dummy to D-U-M-M-Y. It's called dummy because the factor is being converted into values, no? And what are those values? 0 and 1. Okay, so frosh ulit to 0, 0, 0. Sophomore 1, 0, 0. So 1 to. Senior 0, 0, 1. Junior 0, 1, 0. So take note, kahit anong instance, maka-capture nito. Maka-capture ng dummy variables natin. And we're only going to introduce 3 dummy variables because as the rule is, kung ilan yung levels natin, dapat the number of levels minus 1. Yun ang natin, yun ang number ng dummy variables. Okay, may see, may nag-chat. Okay, good, thank you. All right, so balikan na natin class, ha? Let's see now what, let me clear the drawings first. Let's go back to our model. Okay. Take a look again at our mod 2. All right. So we now have here, tingnan nyo to, race white. Now, bakit in-attach si race white? Okay. Okay, remember, class, na sa race, sino yung natin? Sino yung benchmark natin? Sa race, ang benchmark natin, di ba si non-white? Non-white. Okay? Which means, ito class, itong values na to, these are values for non-white. No? Kasi si non-white equal to 1 yan. Si white natin equal to 0. So how do we now interpret this? It is now to be interpreted in relation to your benchmark variable, which is non-white, or reference variable. The reference variable or the benchmark variable is the one that gets the value of 1, and in R, it's the one that appears alphabetically first. Okay? Wala namang kaso yun kung sino mauna. Basta alam natin i-interpret. No? So how do we interpret this? As regards race, ang sinasabi dito, assuming this is significant, hindi lang siya significant. Ang ibig sabihin nito, on the average, white people receive around $11.11 more than their non-white counterparts ceteris paribus. So itong value na to is interpreted for this in comparison with your benchmark variable. So si white daw, on the average, gets $11, 11 centavos more. Bakit more? Kasi positive siya. Than whom? Than their non-white counterparts, employees. Okay? Bakit ganun interpretation ko? Kasi si non-white class, siya yung benchmark natin. So this will be interpreted relative to your benchmark. How about this? 1.76. Ito, si gender, significant. No? This is significant. So this will form part of your equation. So, anong sabi dito? On the average, okay, male employees receive $1.76 more. Bakit more? Bakit more, class? Kasi positive to. If this was negative, then dapat less. More than their what? Female counterparts. So always in relation to the benchmark or reference variable. So kino-compare natin yung male kay female. So 1.76 more si male relative to the female, no? So pwede nating aralin later on, meron bang discrimination dito? Kasi significant yung male na yan eh. Bakit si male on the average $1.76 more than their female counterparts? Of course, ceteris paribus yun, no? Not looking at the other factors. All right. Tapos, ito naman, single in relation to married. So, assuming this is significant, okay, single employees on the average receive $0.46 less because of this negative yield, less than their married counterparts, ceteris paribus. Okay? All right. So that's how we interpret, no, yung mga factors na to. Yung mga factors na to. So first, importante, alam natin kung ano yung benchmark. And R makes it easy for us kasi sasabihin na niya kung ano yung hindi benchmark. No? Kung white to, therefore, si non-white yung benchmark. Kung male to, therefore, si female yung benchmark. Kung single to, therefore, si married yung benchmark. So everything is interpreted in light of your reference variable. Okay. So clear, class? Clear ba yun? Okay. So technically, class, magagawa na natin equation. And only those that are significant will enter the equation. Pero let's not do that for a while, no? Ang gagawin natin ngayon, di ba, meron tayong, we have here model 1. Model 1 to, di ba? Model 1 to, no? I-compare natin ngayon yan kasi we have to test, no? Compare natin yan kay model 2 pala to, model 2. Let's compare that with model 1. Alright? So, babalikan natin yung concept, ha? So, let's see. Alright. So, si model 1, ano yung predictor niya? Education lang. No? Si model 2 naman, lahat to. Education, experience, tenure, race, gender, civil status, number of dependents. Okay, ngayon, ang tanong, how do we now interpret this? Okay. How do we interpret this? Ito, yung Anova natin. Remember, class, si Anova, analysis of variance yan, di ba? Okay, and may null hypothesis yan. Okay? May null hypothesis to. Okay, anong natin dito, class? How do we now interpret this? Now, we will interpret this now in relation to Model 1. Okay? So, ang gagawin natin, mag-a-ANOVA tayo comparing Model 1 and Model 2. Therefore, ano yung magiging null hypothesis natin if we're going to compare Model 1 and Model 2? It will be, null hypothesis is B2, which is your experience, is equal to B3, is equal to B4, is equal to B5, is equal to B6, is equal to B7. Kasi pito, di ba? 1, 2, 3, 4, 5, 6, 7. Okay, is equal to 0. Okay, but hindi natin sinama si B1. Kasi common si B1 sa kanila. Si education kasama sa Model 1, and so is education included in Model 2. Right? So ang naiiba lang sa kanila, itong B2 hanggang B7. Now in this case, model number 2 is now your unrestricted. Model number 1 is now your restricted. Di ba kanina baliktad, di ba? Kanina si model 0 is your restricted, si model 1 is your unrestricted. But I said again that relative yan. No? So titingnan natin, does this make sense? Okay. What would be our inference here? Actually, makikita natin dito. No? Okay, ito. So ito, ang conclusion niyan, we reject the null hypothesis that B2 is equal to B3 is equal to etc. No? Okay? But let's do that. No? Mag-ANOVA tayo para clear sa atin. Okay, so here, ako dito, Control Alt I, ANOVA, no? ANOVA ni Model 1, Model 2. Alright. So we're now comparing here Model 1 and Model 2, where Model 1 is your restricted, Model 2 is your unrestricted. Let's run this. Okay, take a look at this, class. Take a look at this. Okay, so Model 1 natin, early wage regress on education. Diba yan ang Model 1 natin? Diba that's our, okay, Model 1 to. No? Isa lang yung regressor natin. Si Model 2, lahat. Lahat. 1, 2, 3, 4, 5, 6, 7. So, ang null hypothesis natin dito is, again, B2. No? Hindi kasama si B1, no? Is equal to B3, is equal to is equal to B7, is equal to 0. So are they 0? No? Are they 0? And the conclusion is, okay, ito. We reject the null hypothesis, this one. There's strong statistical reason to believe that, okay, at least one of this is 0. Or, what's another way to put your null hypothesis here? Your restricted model is better than your unrestricted. So ano answer natin dito? We reject this. Mas maganda si unrestricted. No? Kasi at least one of these B2 up hanggang B7 is not equal to 0. In fact, compare natin dito. No? Okay. Ilan yung multiple R squared natin? 37%. Which means that Model 2 is able to explain 37% of the variation of your hourly wage as compared kanina to 16.48 something lang. And even the adjusted R squared, 36.19. No? Kahit ang gamitin natin, which is dapat 36%, 0.19, mas mataas to kaysa dun sa kanina na yung kanina 16.32% lang adjusted R squared. Alright? Diba? Okay. And then, just take note here, magkaiba yung F statistic dito. Yung F statistic dito, 43.54. Dito naman, 28.202. Bakit? Bakit, class? Kasi yung F statistic dito, you're comparing Model 0 and Model 2. Okay? Model 0 and Model 2. Ito naman, ang kino-compare natin dito, Model 1 and Model 2. Dinefine natin, no? Diba? Model 0 and Model 2. Had I, okay, tinan nyo had I made this Model 0 and Model 2, i-run natin to. Okay, ito. 43.54, which is this one. Ito yun. No? Kasi yung default natin sa LM natin, linear model natin, ang gino-compare niyan is walang predictor versus yung model 2 natin. But that's not what we want. Gusto natin i-compare si model 1 natin at saka si model 2, no? Balikan ko tong model 1. There. Si model 1 natin, yun. Okay? 28.2. Right? And if you want, pwede natin kunin yung ilan ba talaga yung F statistic nito, no? How do we get that? So if you want to really get the p-value for this one, okay, pwede natin kunin yung PF, which I'll leave you as an exercise to compute, no? Or pwede nating, di ba may model 2 tayo di ba? Model 2 natin maraming predictors, no? Model 2 and then dollar natin, pwede natin kunin tong asan na F? Model 2 at wala F statistics, dapat meron to okay. Bakit ayaw niya kunin? Okay. Let me see. Summary. Summary ng model 2. Okay, sorry hindi. Pamali yung ano ko. Is it the summary of Anova? Nag-Anova ba ako dito? Hindi ako nag-Anova Wait. Let me check. Anova 1. Okay. Hindi ko makuha, no? So, sorry. I-ano ko na lang, class. I'm going to chat it in the chat box sa canvas natin. Hindi ko makuha yung F stat. Alam ko pwedeng kunin dito yun. But we can of course use the okay, we can also use the PF, no? Probability ng F natin. Okay? So ano yung Q natin? Our Q is this one, 28.202. Control C. Control V. Okay, that's our Q. Degree of freedom 1, ito. Degree of freedom 1, ilan yung predictors natin? 8, di ba? DF1 is equal to 8 predictors. DF2 natin is n minus k minus 1. 526 minus k. 5 minus 1, that's 5. Tama ba? 526 minus 8. 518 minus 1, 517. N minus k minus 1 pa pala, no? So, it's 518, sorry. Okay. And then, lower that tail is equal to false. Check ko lang kung tama to, no? Alright. So, this is the p-value, no? Okay. Hindi siya 2.2 e to the negative 16. It's 1.82 times e to the negative 36. So, it's a lot smaller than this. So, yung conclusion pa rin natin, we reject the null hypothesis. Okay. It's time na, no, class? Just one last question. So, is this our final model? Hindi, class. Hindi yan ang final model natin. We will have to do what we call stepwise regression. Okay, so what's stepwise regression? We will have to remove one at a time yung mga variables na which least explained the model hourly wage. So how do you find that? Look at the t-value. So ang hahanapin nyo, class, sa t-value, look for the t-stat, yung pinaka-minimum, absolute value. Okay, minimum na t-stat, no? So dito, sa mga t-value natin, ang pinakamaliit dyan is raise, 0.257. Okay, therefore, syempre, ang aalis ng class yung hindi significant, no? This will now become your leading variable. Aalis siya, no? Leading variable siya. All right? So with this leading variable, okay, let me just last Nasa to class? Leaving variable. So si race, so ang mangyayari dito, class, Control Alt I. Tapos, copy lang natin model natin, this one. Alright, I'm going to copy this model. Control C. And then Control V. And I'll call it model 3. Alright, then tatanggalin natin si race. There. Remove race. No? Remove race from your predictors kasi siya yung pinakamaliit na least significant siya. And then model number 3. Like if I run this, okay, we now have a new model. Yeah, si model number 3 na. And notice that your multiple R squared went up a bit, I think. Your adjusted R squared also went up a bit. Okay. And then I can quickly, no? I-test natin quickly Anova, no? Anova. Compare natin si model 2 at saka si model 3. Okay, take note, ang kaibahan nila, isang variable lang, di ba? Sino yung unrestricted dito? Sino yung restricted model? The restricted model is model 3 kasi mas konti siya. Okay, si model 2 is the unrestricted kasi mas marami siya. Model 2 may race eh. Model 3 walang race. If I run this class, ano mangyayari? Look at the p-value. Okay? Look at the p-value, 0.79. So, we fail to reject the null hypothesis. Anong null hypothesis natin dito? The restricted model is better. Okay? Ibig sabihin nun, class, yung race, ang hypothesis natin, race is equal to 0. So, we fail to reject the null hypothesis that race is equal to 0. In fact, race indeed is equal to 0. So, wala siyang kino-contribute na predictive capability or explanatory capability in explaining hourly wage. All right? Okay, so, is that the final model? Not yet. Ano susunod na gagawin? You do the process again. Tingnan ko ano yung pinakamaliit na t-value. Okay? Remove that until such time na lahat significant na. And that will be your final model. Okay? So, dapat lahat significant na at 5% level, and that ends your final model. Tapos magagawa nyo na yung equation. Kung ano yung equation natin. Okay, so as your exercise, kindly continue with what we call the stepwise regression. Okay, i-check nyo every time na nag-ano kayo kung mas maganda nga yung restricted versus unrestricted. Okay? All right. So thank you so much, class, for your patience. Let me stop recording. Sir? Yes? May questions ba?
Pwede po ba yung pag-quiz? So if we can guarantee that everyone will bring laptop na sa laptop na lang po.
How will I know? Okay.
Maybe we can have a consistent.
Tsaka pag yung isang section, pag yung kabilang section, wala ring laptop. No? So I cannot kasi create another exam kasi mahirapan ako kasi magkasunod. Kung magkaiba yung exam, so it should be pasensya na, it should be as much as possible the same, no?
Okay.
Kasi syempre pag naka-laptop kayo, mas hihirapan ko yun kasi may ano na eh, andyan na yung output. Ang mga tatanungin ko yung mga more on questions about the output. How do you ano yung value nito? Ano yung interpretation niyan?
Okay, sir, wag na po pala.
Okay, meron tayong, of course, yung mga susunod na exam group, no? Ganun na, no? Talagang output-based, hindi na, ano. Just for these exams, no?
Yes, sir.
All right, sige. Thank you so much, class. Okay, stop recording.